In the given diagram, each resistance is same. Suppose I say each resistance is having value R ohm, and we have to calculate the equivalent resistance across A and B. Again, we will connect a supply. Let me connect a supply of 100 volt like this. It means at A potential is 100 volt, at B potential is 0 volt. Suppose this cell supply the current I. It means net resistance, if I have to calculate, that is V upon I, it is 100 upon I. If I am able to calculate, the value of the I resistance can be calculated. Now here we observe at point A, this current will split into three parts like this. Similarly, if you observe at point B, all of you will observe the identical situation. The situation is same exactly at the A point. And if you observe this path and this path, it is having identical resistance. So here current distribution will be same. Suppose I say here is a current I1, here is also current I1, and due to identical situation, here is current I1, here is current I1. Now, assume in this situation current flowing is I2, definitely due to symmetry, same current will come out from this path. It means net resistance can be calculated, that is 100 upon 2I1 plus I2. Now what we want? We want the value of the I1, I2. So finally we can solve it. Let I say at this point potential is X. Now in this resistance is same, current is same, potential difference must be same. So here also potential is X. Now here is current I1 is flowing, here is also current I1 is flowing, same resistance, potential difference is same. Here potential difference is X, here it should be X, it will be X when I write here 100 minus X. So by symmetry I will say here also 100 minus X. Now we come to this path. Here there are two resistors, both are identical and same current is flowing. It means if 100 volt potential difference between or you can say across A and B, then at this point potential must be 50 volt. So that the potential difference will be same and current will be same. Clear? Now we write the KCL equation for X volt. This is the X region. Suppose I say this X. What I will say, that is X minus 0 upon R plus X minus 100 minus X upon R plus X minus 50 upon R equal to 0. We will solve it for X. When we solve it for X, you please pause the video, solve yourself the value of the X, then finally I1, I2. X you will get 75 by 2 volt. Now X you have calculated. R net can be calculated 100 upon 2I1. I will say 2. What is I1? X upon R plus I2. I2 can be written as 50 upon R. Put the value of the X and get the result. You will say it is 4R upon 5. So this is a method to solve the symmetry. Okay, but I will explain you with one more way as I have discussed in the capacitor. Here across A and B, what we observe, there is a perpendicular axis symmetry. It means toward the, I can assume this is the mirror and this is the mirror image. So in the capacitor chapter I told you, when such situation you get, we neglect all the resistance which are on this path. Here no resistance is connected. Second thing we say, on this path potential is same everywhere. It means what we can do in this situation, we can redraw the circuit like this. You can keep it far away because there is no potential difference here and that end, so you can keep it far away like this. Now you will say this is A point, no, this is B point. Now I think it is very easy. You can easily calculate what is the final answer, because now directly you can calculate. So I will not explain you, of course. You should calculate yourself. This is R, this is R, this is 2R. Then 2R and R both are in parallel. Then finally this combination is in series with R and R. In this way we get 3 resistance, and finally we will solve it, and I am sure you will get the same answer, 4R by 5. So to solve it fastly in some symmetrical situation, we will use the perpendicular axis symmetry or parallel axis symmetry like we have discussed in capacitor chapter. Okay, now I want to ask you a question. All of you try to solve yourself. Pause the video, then listen me. Very good question. Here what is given us, that is a nichrome wire of uniform cross section area is bent to form a rectangular loop ABCD. This is the rectangular loop A, B, C and D. Another nichrome wire of same area of cross section is connected to form the diagonal AC like this. We have to find out the resistance across BD and AC. We have to calculate this ratio. Okay. And here length is also given. All of you know formula R equal to rho L by A. Rho is same, A is same. It means you can say R is proportional to L. It means I can say here resistance is 4 ohm. 0.4 meter means 4 ohm. Here resistance is 3 ohm. It is a rectangle. This is 3 ohm. This is 4 ohm. And this must be 5 ohm. Okay. Now, I think it is very easy to calculate resistance across arm AC. I think I need not to explain you. You can say there are 3 resistance, 7 ohm, 5 ohm and 7 ohm, they are in parallel. So when I say, you can use the formula 1 upon R1 plus 1 upon R2 plus 1 upon R3, or you can say 1 upon 7 plus 1 upon 5 plus 1 upon 7, and you will solve it and you will get the result 35 by 17 ohm. Okay. Now to calculate the resistance across BD, it is not so easy. You have to use Kirchhoff law or some other application. Suppose I use the Kirchhoff law here. Let me use another color so you will get the idea. Let us assume here the current entering, that is I, and this current is going out from this end, that is I. Okay. Now this I divide into different branches. Here the current is I1. Here current can be written as I minus I1. In this branch I assume current is I2, and in this branch current can be written as I minus I1 minus I2. Then I1 from this side, I2 from this side, you will say it is I1 plus I2, and finally you will say net current is I. Okay, no problem in it. Now you can use the Kirchhoff law, and with the help of Kirchhoff law you can make the equation. Like I use the KVL for the path. If I say this is BCAB, BCAB. What we get? Minus 3 I minus I1 minus 5 I2 plus 4 I1 equal to 0. Then I write the KVL equation for ADCA path. What we say? Minus 3 I1 plus I2 plus 4 I minus I1 minus I2 minus 5 I2, this must be 0. So we are getting two equations, and when we able to solve these two equations, we will get the value of the I1 I2 in terms of I. So I request you, please pause the video and solve yourself the value of the I1 I2. You will get I1 is written as 8I by 17 and I2 is written as I by 17. Okay, up to this it is clear to all of you. Now, how I will calculate the resistance across branch BD? Let me use another color. Just a minute. Suppose I say across this branch, I say voltage is V. Okay, or I say here the voltage is VA at the B point, voltage is VB. Let me write this, and here voltage is VB. Suppose now I take this new path from B to A to D, then outer side, then I come. I think it is not visible to in slide. Last here, yes, up to this. So don't count this V. You can say it is VB and VD. Now I am writing the equation. I start from VB, then along the direction of flow of current minus 4 I1, along the direction of flow of current minus 3 I1 plus I2. This must be equal to VD. Okay, then VB minus VD equal to 4 plus 3 7 I1 minus 3 I2. Just check it. If there is any mistake, we can correct it. All of you. 4 I1 clear? Okay. Plus this is I1 plus I2. I'm sorry. This is I1 plus I2. Yes, you are right. So this is 7 I1 plus 3 I2. Put the value of the I1 I2 here. You will get VB minus VD, and VB minus VD, I say it is I, and resistance across BD. Now it is 7. I1 can be written as 8I by 17 plus 3I by 17. We can calculate resistance across BD in this way. Okay. So when you will solve it, you will get 59 by 17 ohm. Now I have to calculate the ratio. Ratio across BD and ratio across AC. When we solve it, you will get 59 by 35. Is it clear to you? Check it. The ratio should be this. Now, I have to find the current in the circuit using KVL, and I have to find voltage across A and B also. There are two batteries. One is dead battery, another is live battery. Diagram is given there. It means one is charging, another is discharging. Okay, there may be possibility, and direction of flow of current is given here. Okay, so if I observe and I want to solve it, okay, firstly all of you solve it. I will discuss just after some time. Okay, so we will use KVL. Sum of potential drop is 0. We start from the loop at point A. Along the direction of flow of current, it's minus 4I, then it is minus 4 volt, then minus 7I, then plus 12, then minus 2I, again minus 3, and you are reaching the same point, so it is 0. Okay, so we get This is the answer. I should be 0.5 ampere. Now we have to discuss VAB. We start from B point and move to A point. 12 minus IR equal to VB. So I think it is not written here. You can write. Let me write here. VB and plus 12 minus 2I minus 3I, this should be equal to VA. Now you can calculate VB minus VA or VA minus VB, whatever you require.